Okay, lesson 72, using the properties of logarithms. So if we have y equals b to the x power, and we want to find the inverse of it, we would swap the two variables. And then we can write it in logarithmic form. So y is going to equal the log base b of x. And that would be the inverse of the original equation. So these two are inverses. So remember that the base b goes here, the exponent it's what it equals, and goes out here, and then the x itself would be with the base. Tam?
So is that normal switching an equation, an exponential function to a logarithm?
Finding an inverse if it's an exponential equation, yes.
So that's how it normally is.
Mm-hmm. Yeah. Because when you're finding inverse, you always have to solve for y. So you swap the letters, but y is not by itself. So you have to change it to logarithms. I would like to teach, let me teach the lesson, we'll ask questions at the end, so we're not here forever. Carter?
Well, I'm just wondering, because you say inverses, are you just pointing to the two?
Yeah, this one and this one. Tally?
Wondering, could you ever have an exponent that's a logarithm?
Mm-hmm. Yep. So we have what's called the inverse properties of logarithms. I'll just call it logs instead of writing out logarithms. If you have b raised to the log base b of x, that will equal x. And if you have log base b of b to the x power, that just equals x. So if I just put in some numbers for b and x, if I had 2 raised to the log base 2 of 3, if you see this base and this base are the same, then the answer is just 3. Or another example, if I had log base 2 of 2 cubed, these two are the same, so the answer is just 3. Tam?
Why?
Because of the inverse property of logarithms. And I'm also going to show you when you raise a logarithm to a power, it's the same thing as multiplying this number times that. So it's x log base b of b, and we already know log base b of b is 1, so it's just x. Yes, Tim?
So 2 and log base 2 are opposites.
No.
They're inverse.
No. You're confusing me now.
I'm confused though.
Okay.
So 2 the log base 2, 3.
Here, let me give you an example, Tan. You can do this. 3 to the log base 3 of x plus 1. What does that equal?
Equals x plus 1.
There you go.
But
You're
I
done.
wanna know why.
Well,
Because
I will show you
Just accept it.
more of it later, okay? It's just taking up all of my class time
Okay.
to show you the whys behind everything. But it's, okay.
Call me an
Change of base formula. So if your a is greater than 0, and does not equal 1, and you have any base b such that b is greater than 0 and b is not equal to 1, then we can say that the log base b of x is equal to the log base a of x over the log base a of b. Usually the reason why we want to change the base is so that we can get it in base 10 and we can get a calculator and use it with the calculator. So for example, if I had evaluate log base 81 of 27. Well, I can't do a different base on my calculator, but I can change the base to base 10. So I can do log of 27 divided by log of 81. And then that would give you what that would equal if you just plug it in your calculator. Heidi?
Okay, so for the first one, sorry. But like the one we know where x, so the one that x equals, it's always going to be that number. Like that's what the answer's going to be.
I don't know what you're saying, but I guess so.
Well, in the one before the change of base formula.
Right here?
Yeah, the x is always going to be like the value that is given for, right?
Right here?
Yeah.
If
Okay.
these two are the same numbers.
Okay.
So this would be 3/4 or 0.75. So the log base 81 of 27 is 0.75. So if I raised 81 to the 3/4 power, I would get 27. That's just what that means. Then we have what's called the product quotient, and this is going to help Tan with his earlier questions, properties of logs. So for any number, well, it has to be positive. I'm taping. So what do you need? Quickly? Thanks. M, N, and B, but B does not equal 1. Log base B of M times N. So if you are taking the logarithm of two numbers multiplied, it equals the log base B of M plus the log base B of N. So you can separate it out and add those two together. And then this one, log base B of M divided by N equals, we're going to separate them out just like this one, but we put a minus sign between there. Nope, this isn't the one I wanted to. It's the power property. That's the one I want, the next one. So I'm going to show some examples on this one, but I have to turn the page. So, right quickly. Yes, Tan?
I forgot how to do a normal log.
Okay.
So,
Okay. So we're going to say approximate the value of log base 2 of 80. I think they gave us. No, they didn't. Okay, so we want to use the fact that log base 2 of 5 is approximately 2.322. So we could say 5 times 16 is 80, right? So we could do log base 2 of 5 plus log base 2, and 16 is 2 to the 4th, which we just learned earlier. Log base 2 of 2 to the 4th would just be 4. So we're going to do 2.322 plus 4. 6.322. 10?
so I used the log 80 divided by log 2, and I
Yes.
got the same thing.
Yes. Excellent.
So you have to do it like that.
No.
And how did log base 2, oh wait.
I'm gonna do some more examples, okay? Approximate the value of log base 3 of 25. And in order to do that, we want to use, this is part of the problem. When I say use, if they tell you to do that, it'll give it to you, like part of the problem.
Like, so I can't do the log of 25 divided by log 3?
It should work.
Yeah, but
It should
says
work.
use log
Yeah.
3 of 25. Okay.
So if we're supposed to use the log of base 3 of 125, I want to think in my head, how is 25 and 125 related? Right, but could I yeah, Spencer.
Can you divide both of them by 25? Because 125 goes into, 25
Yeah.
goes into 125 5 times.
5 times. So I could do this right here. Log base 3 of 25 is the same thing as log base 3 of 125 divided by 5. True?
Yeah.
Okay. So then we have, then we could subtract. So log base 3 of 125, which they gave to us, minus log base 3 of 5. Uh-oh. I think I was supposed to tell you what log base 3 of 5 is. Oh yeah, I was. Whoops. I'll write it up here. Log base 3 of 5 is approximately 1.465. Okay. So then, because we're subtracting, we just subtract those two numbers. And we get approximately 2.9299. And you should get the same answer if you do log
Yeah, you did.
25 divided by log 3.
So can you just line on your paper and pretend you did the work, but actually you did the other way?
No.
Just the other way makes more sense.
Yeah, that's what they just think.
No.
Yeah, exactly.
No, I'm gonna look at your work. If it says to use that, I have to see your work. One more property we have to go over. Carter,
How did you get the 4.3949? If I'm not
it came with my problem.
No, but like, how do you do that on a calculator?
You do log of 125 divided by log of 3.
Can you just
Yeah.
So the other way to get that answer above the 2.929, you would do,
Oh, yeah,
you would do log 25 divided by 3,
log 3.
log 3 divided by,
No,
wait,
log 25 divided by log 3.
oh.
Yeah,
So
that's the other way. For any real number p and positive numbers, as long as b doesn't equal 1, the log base b of a to the p power equals p log base b of a. Which, so if it's raised to a power, you can bring it down in front and then find the log of base b of a. So let me do an example. Log base 4 of 64 cubed. You could bring the 3 down. So it's 3 log base 4 of 64. But I know 4 goes into 64 if you cube it. So I'm going to change that 64 to 4 cubed. Haha. Then I could bring this 3 down in front, times it by that 3. So I get 9 log base 4 of 4. And I already know log base 4 of 4 is 1. So that would be 9.
Wait, can you do that again?
Super awesome.
Can you do that
I
again?
will
What if I just went
in
straight
1
to
second while I
the
stop this video.